Okay, in this problem, we're told that there's a mountain that is at some distance from a base camp, and we're told that the peak of the mountain is at a height of 2,600 meters. And so if the x and y represent the flatness of the land and the z would be coming out of the page, we would go up 2,600 meters, and that would be where the height would be. Now, the reason that I've oriented my coordinate system this way is because it tells us in the problem that they want the x-axis to line up with the east and the y-axis to line up with the north. And so I've just rotated my normal three-dimensional coordinate system to make that. And then we're told that the distance from the base camp to the summit is from, let's see, what does it say? It's 80 meters at 33.4 degrees. And that is west of north. So that's going to be over on the other side. So it gets a little bit complicated when you're dealing with this in 3 dimensions. So let's just look at 2 dimensions, because the 2,600 meters straight out of the board or out of the page, that's pretty easy to keep in our heads, and we'll just think about that later on. But, okay, so let's look at just what we have as a displacement in the xy plane. The z displacement is going to be coming out of the board or out of the page. But if we look at what they say in the problem, we're told that there's a 50-80 displacement from the base camp to the peak of the mountain, and that we're given that the angle theta is equal to 33.4 degrees. And again, this x is aligned with the east, and the y is aligned with the north. That would make this the south, and this the west. And we're told that the angle is west of north, so that's how I know it's from the north axis or the y-axis down, and that angle is 33.4 degrees. So we want to find the x and y components of that displacement. So that is going to be the x component, and that's going to be the y component. And so the y component actually is the one that goes with the cosine, not the sine. And so you asked me how you got them flipped. I'm guessing that that is probably what you did, is that you mixed up the sine and the cosine, because this is the adjacent side. So the y component is going to be the, what was it, 50-something, 50-80. So the x component, this is r, this is going to be r sub x is going to be 50-80 times the sine, because that's the opposite side. And then the ry, so this would be my ry, this would be my rx. My ry is going to be 50-80 times the cosine. And so, and of course, there would be meters for each of those. And I think that that's probably where you made your mistake. If that's not it, let me know, and I will try to answer the question another way. But anyway, that will give you your x component and your y component. Now, one thing to note is that this x component here is pointing in the negative direction. So this is actually going to be negative. I should have written that in. But so your x component is going to be negative. Your y component, that's pointing in the positive direction, so it's going to be positive. And your z component, which is coming literally out of the page towards us, is going to also be in the positive z direction. So, and that was given to be 2,600. So your RZ is just 2,600. Anyway, I hope that helps. If it doesn't, let me know, and we'll figure out what you're not understanding.